So, good evening, everyone. This is the presentation about automatic plant watering system using Arduino, and this is our team: Prachi Gurav, I am Pradyot Soni, Prakhar Shukla, Saurya Gupta, Unik Yadav, and Ved Vekhande. So, in this presentation, the flow of our presentation will be like we'll be starting with introduction, then we'll be explaining about the components used, the working methodology and algorithm. Finally, we'll jump on to the video of our working model and the conclusion. So, starting up with the introduction of the automatic plant uh, watering system using Arduino. So here we have used real-time soil moisture reading that enable optimal hydration with minimized water waste. And here this LED presents soil moisture and system status for easy monitoring. Arduino Uno relay module and soil moisture sensor automate watering, eliminating manual intervention. Controlled intervals and volumes promote healthier plant growth by meeting individual plant needs. So now I would like to hand over to Ved to explain the components used.
Thank you, Pradyot. So myself, Ved Vekhande, and my student ID is 202111087. So the components that we have used, the very first component that we have is Arduino Uno. So at the very heart of our automatic plant watering system, we have this Arduino Uno. So it is just like a central processing unit and is responsible for interpreting data from our sensors and controlling system components. So it actually serves as a brain of our operation. The next we have is relay module. So this is one of the crucial component that facilitates control of higher power devices such as water pump in our case by lower power Arduino Uno. Next we have is LCD module I2C. So our system wouldn't be completely without the LCD module, and this serves as an interface so to get the output on our device. So, and real-time information such as soil moisture levels and system status would be displayed using LCD module. Next that we have is water pump. So, this component is responsible for delivering water to our plants based on soil moistures. Uh, by ensuring that our plants receive the necessary hydration precisely when needed, the water pump actually plays a crucial role in pumping the water. The very next component that we have is soil moisture sensor. So this sensor is measuring the soil moisture levels in the soil and providing crucial input for the Arduino. Uh, and by continuously monitoring the moisture content of the soil moisture sensor would actually enable our system to respond dynamically to the watering needs of our plants and thereby ensuring that they receive optimal hydration. Uh, next, next I would like to call Shwara.
Thank you, Ved. Myself, Saurya Kumar Gupta, roll number 076. Now, I am going to cover working my model of our project. First, we are going to gather the components Arduino Uno, soil moisture sensor, relay module, LCD I2C interface, and water pump. Now, after that, we have assembled our hardware based on the provided circuit. After that, we have uploaded Arduino Uno, our code in Arduino IDE to read the sensor data, control relay, and they update the LCD. After that, we have calibrate our sensor, determining the dry and the moist soil reading to set watering thresholds. I'm going to hand over to Prachi Guru. Prachi, you can continue.
My name is Prachi Gurav. So the next step we did in our project was to test the system. We did this by ensuring the power on off, and then the verification of sensor accuracy, and then we tested the water functionality. Then for the better results, we optimized our code. So in this step, we fine-tuned the code based on the test results as well as the user needs. And the last step we did was install and monitor. In this step, we install the system, monitor its operations, and make adjustments as needed for optimal plant care. Now I'll hand over to Unique for explaining the code.
Thank you, Prachi. Myself, Unik Yadav. My institute ID is 202111083. Now, uh, first we have a function of liquid crystal I2C. In this function, we given a parameters 0 to 7 means it has a LCD display module given a L2C address, and 16 is the parameter of indicating the 16 columns of the display, and 2 display the rows the LCD display. And we set a sensor pin A0 and relay pin set to 7. And in a setup function, we in a setup function, first begin with 9600, and LCD begin with 16 as the column, and 2 is the row of LCD. And in this first set backlight of high and pin mode sensor for input, and relay pin for output. And in this loop function, we use analog read for sensor pin. And then if our sensor data is greater than 950, it means soil is dry and motor is on. And else if sensor data is greater than 400 between 9 and 50, then soil is medium and motor is off. If another condition, sensor data is less than 400, means soil is wet and motor is off, and set the cursor at 1. And we use delay function for 1 millisecond, and this is our algorithm. Now I would hand over to Prakhar Shukla.
So I'm Prakhar Shukla, and my student ID is 20111067. And now we are going to present a video of a working model.
So we have made automatic plant watering system using Arduino, and currently the reading on the LCD sensor is that the soil is dry with the value of 1019, which is the exceeded level value. And now we will switch that on, and we can see that as soon as it is turned on, through the relay module and through the water pump, we can see the flow of water, and now we can see that the soil readings also changed.
So now for the conclusion, we can say that the automatic plant watering system successfully respond to the input and correct reading is observed on the LCD module. Thank you.